Welcome to second lecture of periodic table chapter. In the previous lecture, we had discussed about evolution of the periodic table and how different scientists contributed to the development of periodic table. In the end, we had discussed Mendeleev's periodic table. So, in the beginning of 20th century, isotopes and subatomic particles like electrons, protons, etc., all these things were discovered. Now, these discoveries proved that Mendeleev's table was not correct and it needed improvement. So, in 1913, Henry Moseley conducted few experiments with X-rays. And when he conducted all these experiments, he observed that the frequency of the X-ray was directly proportional to atomic number of the element. So with all these experiments, Moseley proved that atomic number is a fundamental property of element and not atomic mass. So before that, everyone believed that atomic mass was the fundamental property of every element and the periodic table was based on atomic mass. But now Henry Moseley said that atomic mass is not fundamental property, atomic number is the fundamental property. So in this way, he proposed a modern periodic law. So the modern periodic law says that the physical and chemical properties of elements are periodic functions of atomic number. So atomic number of element determines their properties and not atomic mass. Now after Moseley gave his modern periodic law, the modern periodic table or long form of periodic table was developed. So now Mendeleev's table was stated incorrect and a new periodic table, that is long form of periodic table, also called modern periodic table, was developed. So let's see the important features of modern periodic table. So in the modern periodic table, elements are arranged in 7 periods and 18 groups. Now periods are the horizontal rows and groups are the vertical columns. So periods are horizontal and groups are vertical. There are 7 periods in the periodic table and 18 groups. Now let's see how the elements are arranged in periods and groups. So all the elements having same valency are put in the same group. So same valency elements in same group, in same vertical column. So for example, in the group 1, there are elements like hydrogen, lithium, sodium, rubidium, etc. All these elements have valency of 1. So here you can see that all the elements having same valency will be put in same group. Similarly, in group 2, all the elements will have same valency, that is 2. And similarly, it will be same for other groups. Now on the other hand, in the periods, the elements are arranged in increasing order. So as we move from left to right in the periodic table, the atomic number of the elements keeps on increasing by 1. So for example, the first element in period 1 is hydrogen and it has atomic number of 1, and second element is helium and it has atomic number of 2. So you can see that the difference between hydrogen and helium is 1. So similarly, as we keep on moving from one place left to one place right, the atomic number keeps on adding 1. Now let's understand nomenclature of elements with atomic number more than 100. So sometimes the same element can be given different names by different nations. For example, the element 104 was given different name by the Americans and different name by the Russians. So to solve this problem, IUPAC, that is International Union of Pure and Applied Chemistry, gives a temporary name to the elements until they are officially recognized. And this temporary name is made directly from the atomic number of element. So how this name is made? Let's understand that. Element name is equals to name for each digit of its atomic number plus IUM in the end. So what we do that, we have given every digit a unique name. For example, the digit 1 has been given the name UN. The digit 0 has been given the name NIL. Similarly, digit 2 has been given the name BI. Digit 3 has been given name TRI, that is try. So similarly, we give the names to each digit from 0 to 9. Now what we do is, to write the element name, we take the atomic number for each digit. So let's see that we have to give the name to an element which has an atomic number of 102. So what we will do is that we will write the name for each digit. In 102, you can see that there are 3 digits, 1, 0 and 2. So for digit 1, you know that the name is UN. Similarly, for digit 2, name is NIL, and for digit 2, the name is BI. So we will write UN, NIL, B, and in the end IUN. So the name becomes UN plus NIL plus B plus IUM, that is UN, NIL, BM. Now for the symbol of the element, what we do is that we take the first letter of each digit. So the symbol of 102 element will become UNO. So let's understand nomenclature with another example. This time we have the example of element with atomic number 107. So now the name of this element with atomic number 107 is bohrium. But let's see how we will find the IUPAC name for this element. So IUPAC name, we will take the name for each digit of the atomic number. So for 1, the name is UN. For 0, the name is NIL, and for 7, the name is sept. So we will just combine them and add IUM in the end. So the final name will become UN, NIL, sept, EM. And for the symbol, what we will do is that we will take the first letter of each digit. So it will become UNS. We shall discuss more about the modern periodic table in the next lecture. Thanks for watching.